Page 58, the answers. What about that satellite in orbit? Objects don't always fall down in a straight line. If you throw a ball horizontally, remember we talked about the ball horizontally going with the horizon, moves away from you while gravity pulls the ball to the ground. The horizontal and vertical motions act independently. That means they act separately. So the ball follows a curved path toward the ground. If you throw the ball faster, it will land farther in front of you. The faster you throw an object, the farther it travels before it lands. So the gravity force will always be the same no matter how far it goes. So look at the picture in the bottom. If you throw it a certain distance, it falls. So this motion also explains satellites, which are objects that orbit around other objects in space. They follow a curved path around the Earth. What would happen if you were at a high mountain and would throw a ball as fast as you wanted? The faster you threw it, the farther away it would land. But at a certain speed, the curved path of the ball would match the curved surface of the Earth. Although the ball would keep falling due to gravity, Earth's surface would curve away from the ball at the same rate. The ball would then fall around Earth in a circle, as shown in Figure 2. The satellite launched from the Earth enters orbit because of the curve its path matches and the curve of the surface of the Earth. On the picture on the right, draw across the representation of the gravitational force on the ball at each point. So right here, where is gravity affecting this ball? The second, the third, the fourth, the fifth, and the sixth. And then explain why Earth's atmosphere would prevent this baseball from ever actually being thrown into orbit. Why is this not a problem for satellites? Well, the answer is air friction would cause the ball to fall to the ground, and there is less air out in space where the satellites are. So air friction is slowing a ball down here, but once it gets out into outer space, that air, which is causing friction, is not a factor anymore. So a satellite will continue to fall, sort of, or the gravitational pull of the Earth will keep it in orbit. So the key factor is satellites in orbit around Earth continuously fall toward Earth, but because Earth is curved, they travel around it. In other words, a satellite is a falling object that keeps missing the ground. It falls around Earth rather than onto it. Once it has entered a stable orbit, a satellite does not need fuel. It continues to move around due to its inertia. At the same time, gravity continuously changes the satellite's direction. Most satellites are launched at a speed of about 7,900 meters per second. That's more than 17,000 miles per hour. Centripetal force. Manufactured satellites orbit Earth in an almost circular path. Recall that an object traveling in a circle is accelerating because it continuously changes direction. If an object is accelerating, a force must be acting on it. A force that causes an object to move in a circular path is called a centripetal force. The word centripetal means center-seeking. Centripetal forces always point toward the center of the circle an object is moving in. If you can turn off a centripetal force, inertia would cause the object to fly off in a straight line. For example, if you have a string of a yo-yo being swung in a circle, that provides a centripetal force, the string. And then cutting that string would cut off the force, and the yo-yo would fly off in a straight direction. So let's apply that centripetal force. What is creating centripetal force in each of the situations? If you have a tether ball swinging around the pole, as here, it is the pull of the rope that is causing it. Mars orbiting around the sun, well, that would be the sun's gravity, or the gravity toward the sun. And if there's a child standing on a merry-go-round, friction is causing the force. And the bottom, let's assess our understanding. What is the force that causes objects to move in a circle? Remember the circle. Center seeking is the centripetal force. B, if Earth's gravity could be turned off, what would happen to satellites that are currently in orbit? And explain your reasoning. Well, the satellites would fly away from Earth, continuing in a straight line in the direction they were going because of Newton's first law. And I get it. Now I know that satellites stay in orbit because gravity supplies a centripetal force. So gravity is always working on it, and the centripetal force is the circle, center seeking.